Here's an alternate way of approaching 2833. In the figure at t equals 0, the switch S is closed, the capacitor uncharged. C is equal to 50 microfarads, EMF is equal to 20 volts, and R is equal to 4 kiloohms. What is the charge on the capacitor when I is equal to 2 milliamps? We have a DC circuit, and if the EMF is equal to 20 volts, that voltage should be shared between the resistor and the capacitor. Hence, if we could find the voltage on the resistor, we would find the voltage on the capacitor, and if we know the voltage on the capacitor, we can find its charge. So that's our plan. Well, the voltage across the resistor is the current times the resistance according to Ohm's law. And if the current happens to be equal to 2 milliamps, and the resistance is 4 kiloohms, then that voltage would be equal to 8 volts. And then we can find that the voltage across the capacitor is the EMF of the battery minus the voltage across the resistor. That'll be 20 volts minus 8 volts, or 12 volts. So that is the voltage across the capacitor. Hence, at that moment, the charge across the capacitor, which is C times V, is equal to the capacitance, which is 50 microfarads, times 12 volts, or 600 microcoulombs. So that's our answer, 600 microcoulombs. Now this is a very risky way of doing this kind of problem because it really doesn't involve any knowledge of RC circuits, just DC circuits in general. And but it actually can be used for many of these problems, so you just have to look out and use this shortcut method if possible. But be aware that you have to use the other methods for other RC applications.